This is a video tutorial on Solution Stoichiometry by Kale and Kyle. So the definition of stoichiometry is the calculation of relative quantities of reactants and products in chemical reactions. There's three main types of stoichiometry. There's gravimetric, solutions, and gases. Today we'll be learning about solutions, and in order to do this, we first need to have basic knowledge of gravimetric stoich. So a gravimetric sample question would be to determine the mass of iron oxide produced during the single replacement reaction of iron and nickel oxide when you are given 150 grams of iron. So we see here the question tells us we have 150 grams of iron and we're solving for grams of iron oxide. So to do this, we have to first solve for moles of iron in order to connect the two with the molar ratio. So we take 150 grams of iron, and using unit analysis, we solve for the number of moles. So we see that every 1 mole of iron has 55.85 grams. Now, our units will cancel out, leaving us with moles of iron. So now we're able to connect it to iron oxide through the molar ratio. To do this, we have to balance the chemical equation. So to balance it, we see that we have 2 irons here and only 1 here. So we have to put a 2 in front. And now we have 3 oxygens here and only 1 here. So a 3 must go in front there. But now we have 3 nickels on this side and only 1 here. So we put a 3 there. Now the molar ratio is for every 2 moles of iron, there will be 1 mole of iron oxide. So now that we have incorporated the molar ratio into our equation, when our units cancel out, it will leave us with moles of iron oxide. And this will be 1.34 moles of iron oxide. Now the question asks us to determine the mass of the iron oxide. So we take the number of moles and we multiply it by the molar mass. The molar mass is for every 1 mole, there's 159.7 grams. So if we multiply these two together, it'll give us an answer of 214. When our units cancel out, it'll be left in grams, 214 grams of Fe2O3. So that is our final answer for the question. So the mass of iron oxide produced will be 214 grams.
We've learned the basics to gravimetric stoichiometry. We can now apply that to solution stoichiometry. Solution stoichiometry is similar to gravimetric stoichiometry, except it involves volumes of aqueous solutions instead of solids, and uses concentrations to find the number of moles. You can then utilize the molar ratio to determine the concentration or volume of a reactant or product. A 10 milliliter sample of H2SO4 reacts with 15.9 milliliters of a 0.15 mole per liter solution of KOH. Determine the concentration of the acid.
So to begin solving this problem, we have to first balance the chemical equation. So we have 2 potassiums here, but only 1 here. So we must put a 2 there. Now we have 2 OHs there, but only 1 on this side. So we have to put another 2 right there. So now the equation is balanced, and we can write in our givens. So it says a 10 ml sample of H2O, which is 0.01 liters. And we have 15.9 mils of KOH, so that's going to be 0.0159 liters. And the question also gives us the molarity, which is 0.15 moles per liter. And so the question asks us to find the concentration of the acid. So we have to use this information to solve for the moles per liter of H2SO4. So to begin, we're going to start with the amount of KOH given. And we're going to multiply it by the concentration. So we're going to have liters of KOH on the bottom and moles on the top. So you see here it is 0.15 moles for every 1 liter. So now those units cancel out, leaving us with moles of KOH. And since we're trying to get to moles of H2SO4, we connect them using the molar ratio. And the molar ratio is for every 2 moles of KOH, there will be 1 mole of H2SO4. So now those units are going to cancel out, giving us moles of H2SO4. And the question asks us for the concentration of the H2SO4. So this time, we don't want the moles to cancel out because that's part of the concentration. So it's going to stay on top. And the liters, moles per liters, will give us the concentration. And we see here we have 0.01 liters. So when the equation is solved and all of our units cancel out, it's going to leave us with 0.12 moles per liter of H2SO4.
So in conclusion, solution stoichiometry is based off of the formula C equals N over V. The C standing for concentration in units of moles per liter, N for moles of the given solution, and V for volume in units of liters. You can manipulate the formula to determine any of the variables if you have already determined the other variables either as givens or from previous calculations. To determine the concentration, it is simply equal to the moles divided by the volume. To determine the volume, it is equal to the moles divided by the concentration. To determine the moles, it is equal to the concentration multiplied by the volume. Thank you for learning with the Kale and Kyle Academy.